and good times. So we are diving into chapter 9 is all about quadratic equations. The bottom line is there are 3 methods for solving a quadratic equation, and you will be required to use all 3 over the time in calculus. So let's start off by just saying that what we mean when we say a quadratic equation is any equation that can be written in this form: ax squared plus bx plus c is equal to 0. Now, it doesn't matter what the letter is. Those a, b, and c values are all constants. And anything that we can write in this form, we consider a quadratic equation. Now, up to this point, the one method we talked about for solving quadratic equations is factoring. I don't know, this pen just doesn't like me. But we have got 3 options for solving quadratic equations. Factoring is my favorite because it really has the most uses for us in calculus. There are a lot of times where factoring is really the only option that's going to be helpful. But the quadratic formula and completing the square are both things that we're going to have to know and use to deal with stuff in calculus. Now, for starters, if I have an equation that doesn't factor, clearly factoring doesn't work. So we have to have a technique to deal with things that don't factor. In terms of the quadratic formula, if you have gotten this far in life without managing to memorize it, the time has come. You'll have to use it in other classes as well. You just have to get it memorized. If this is totally brand new to someone, please slow me down. But my assumption is that people have seen the quadratic formula before. You can always let me know if that is not the case for you. But we've kind of done some factoring stuff. And if we're doing quadratic formula, dun, dun, dun. If we have an equation that's written in this form, ax squared plus bx plus c equals 0, then our quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. All of that is inside of a square root, and the entire thing is over 2a. There are things that I'm going to be picky about when you are using quadratic formula and writing your answers. I'm going to be very picky that this bar extends all the way over here to make sure that your negative b is on the top. It is also totally fine for you to think about this as 2 separate fractions, as a negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And I've seen it written both ways in different textbooks. So it doesn't matter which way you want, but if you're going with the first way, it is important that that fraction bar extends all the way under the negative b. Well, let's take a look at actually using this. So as an example, I'm going to start off with something that factors. So I'm going to start off with x squared minus x minus 6 is equal to 0. Oh, one other super important thing, just like when we're factoring, if the equation didn't start off with a 0 on one side or the other, it is important that that's your first step. So we could solve this by factoring, but let's use the quadratic formula. In terms of quadratic formula, there's an invisible number sitting in front of my x squared right now. And so really I can think about this as saying 1 x squared plus, you don't have to rewrite it this way. I'm just doing it because it's our first one, plus negative 1x plus negative 6. Now I've rewritten it this way just to highlight that our A is positive 1, B is negative 1, and C is negative 6. You certainly do not ever need to rewrite out this line, only do it if it's helpful. So in terms of quadratic formula, I'm going to jump straight to x is equal to, I need to make the negative of b, meaning I'm going to take the opposite sign of b. So that would be a positive 1 plus or minus the square root of, well, b squared. If I take negative 1 and square it, I've got positive 1 minus 4 times a times c. All of that is inside of the square root. And then all of that is over 2 times 1. Now I made a note in the homework assignment, definitely on the quiz, that while you don't have to simplify everything, you do have to get all of that stuff inside the square root down to a single number. Now, if it happens to be a perfect square, then I want you to keep going to simplify. If it doesn't happen to be a perfect square, you can quit. So let's see what happens. If we clean up all of that stuff inside, negative 1 squared is positive 1. 4 times 6 is going to be 24, and a negative times a negative is going to make that plus 24. Which means that inside my square root, I've got a 25. So this is 1 plus or minus the square root of 25 all over 2. Well, this one, I'm definitely going to simplify because the square root of 25 is 5. That plus or minus thing tells me that I've got 2 answers. One answer is that x is equal to 1 plus 5 all over 2. And the other option is that x is equal to 1 minus 5 all over 2. Now that like all over 2 thing means I can keep going to simplify this, but I need to combine the top first. So 1 plus 5, that's going to be 6. 6 divided by 2 is 3. 1 minus 5 is negative 4. And negative 4 divided by 2 is negative 2. If we go back to the original equation, that x squared minus x minus 6 is equal to 0. And if I were to choose to solve that by factoring, I'd be looking for 2 numbers that multiply to give me negative 6 and add to give negative 1. So I'd be looking at x minus 3 and x plus 2, which would have given me solutions of x equals 3 and x equals negative 2. I think this is faster. This is definitely faster for me. So when I encounter some kind of quadratic, I'm going to try to factor it first. But if it doesn't factor, move on with your life. Throw it into quadratic formula. If it did factor, the numbers will work out nicely. And if it didn't factor, you are going to be spinning your wheels sitting there trying to factor it anyway. So my rule of thumb is 30 seconds to a minute If you've spent more than about a minute trying to figure out what the factors are, maybe just go throw it into quadratic formula. For the homework and the quiz, you will be required, some questions will require you to use quadratic formula. Some questions will require you to complete the square, even though no one ever wants to do that. Yes. If there's a solution, they will always work. And if there wasn't a solution, nothing else was going to work either. Yeah. So if there's a solution, quadratic formula always works. Good question. Okay, let's do another one. This time I'm going to pick something that doesn't factor, I think. Sometimes I make things up and then they like accidentally factor. Let's go with 2x squared plus 3x minus 2 is equal to 0. That might accidentally factor, but you already see it. Does it accidentally factor? Whatever. I made it up. We'll just go with it. So if I look at this, my A is 2, my B is 3, and my C is -2. It is important that you're capturing the sign, the plus or minusness of the A, B, and C when you put them into the formula. I am gonna give I'll pull the formula back up, but give everybody a minute to put the numbers into the formula and simplify what's inside of that square root. It did work out nicely in the square root. Okay, well, that's good. If nice things happen on the square root, it must be a factor. There's no writing. The final answers must be nice things. I mean, fractions are nice. Fractions are. Okay. Got a couple of answers rolling in on the chat. If what's under the square root is a perfect square, then you should simplify. But if it's not, you can just stop where you are. So let's see what happens. So if I start plugging this in, I'm looking at x is equal to -3 plus or minus the square root of 3 squared minus 4 times 2 for my A value times -2 for my C value. And then the entire thing is going to be over 2 times 2. So if I go to clean up those numbers inside of my square root, that's going to be 9. 4 times 2 is 8 times another 2 is 16. But the minus and minus will make that a plus 16. And then down here, 2 times 2 is 4. So inside the square root, it looks like it should work out to be 25. Again, sorry, I picked nice things on accident. So that would look like -3 plus or minus 5 all over 4. So because we have nice numbers, we're going to want to actually write those out. So that's -3 plus 5 all over 4 and -3 minus 5 all over 4. Well, -3 plus 5, that's 2. Oh, did I mess up? Oh, no. Oh, because our formula is -b. Yeah. Okay. So -3 plus 5, that's 2. 2 over 4 is 1/2. -3 minus 5 is -8. -8 over 4 would be -2. Which, by the way, means that this thing must have factored in the first place. I bet that means that this thing factors as 2x minus 1 times x plus 2. 2x squared, positive 4x, -x, -2. Yep. Okay. Should we try another one? I promise I'll make one that doesn't factor. -3x squared plus 5x minus 1 equals 0. Okay. I'm 95% sure that doesn't factor. Just as some quick practice here, that means that A is equal to -3, B is equal to +5, and C is equal to -1. And if you don't have the quadratic formula memorized, I recommend writing it over and over and over again. And by that, I mean, each time you do a problem, just practice writing out the formula before you plug any of the numbers in. And if you do that 5 or 6 times, I really think you're going to have it memorized. So give that one a shot. Be super careful about the pluses and minuses when you're going through it. And let's see what we get. Yeah. At least the numbers aren't crazy big or anything. Let's plug stuff in together. So I'm looking at -5 plus or minus the square root of 5 squared minus 4 times -3 times -1. And all of that is inside of a square root. And then the entire thing is over 2 times -3. And if I start to simplify that, that looks like -5 plus or minus inside of the square root. 5 squared is 25. A minus, and another minus will stay subtraction. So that's 25 minus 12. That sounds like 13 to me. And the 2 times -3 is -6. And then we're going to walk away. We did not have a nice thing under the square root. So we're just going to quit right there. If the number under the square root is not a perfect square, the thing didn't factor. So that was definitely our best option. So I want to talk, let me just write another example real quick. Let's see. Let's take 4x squared plus x plus 2. So here my A is 4. My B is that invisible 1 because it's the coefficient in front of the x. And C is 2. If you don't have that quadratic formula memorized yet, here's your chance to practice writing it out again. I'll just keep writing it over and over. Got -b plus or minus the square root of b squared minus 4ac all over 2a. So if I plug this in, I'm going to have -1 plus or minus the square root of 1 squared minus 4 times 4 times 2. And then that whole thing will be over 2 times 4. So if I clean this up inside that square root, that's 1 minus 4 times 4, that's 16 times 2, so 32. So I've got 1 minus 32, which means I've got the square root of -31. This is the place where we're going to say, nope, we're not taking the square root of a negative number. This has no real solutions. There is a mathematical construct of imaginary and complex numbers that allows us to write the solutions to this thing. However, almost all of the time, if we get to this point, we're going to say that there's no solution, because almost all of the time, we really only want to be dealing with real numbered values. For anybody, oh yeah, and so there is another notation for this, right? And the real solution part, sometimes we write as an R with double lines. There is no solution in R. For those of you that are heading on to the 17 series, we will need to be able to deal with complex numbers like this, but not until 17B. So, you know, we'll deal with that when we get there. For now, if you end up with a negative sign underneath your square root, just stop and say that there are no real solutions. Yeah, so notation wise, there's a question in the chat about the use of I. Absolutely, that's how we would deal with this, is using I. But in the context of this class, if you get a negative number under the square root, I want you to write no real solutions. I don't want you to write the complex answers. Okay. More fun? How am I doing for time? I am doing great on time. Sweet. Okay. Just a couple more examples. Let's see. How about if I had 3x squared plus x is equal to 4. If my instructions were to solve this thing, then my first step has to be to subtract that 4. I will leave it up to you. That thing might factor, it might not. You can solve it however you want. Did you all factor or use quadratic formula? Quadratic formula? No one wanted to factor that? Okay. Fine, we'll use quadratic formula. I like factoring. First step, regardless of whether we're going to factor or use quadratic formula, I'm going to have to get a 0 somewhere. So I'm going to write that as 3x squared plus x minus 4 is equal to 0. When I go to put that into quadratic formula, then my b is a positive 1. So I'll have negative 1 plus or minus the square root of 1 squared minus 4 times a times c all over 2a. So if I clean that up a bit, inside that square root, I get 4 times 3 is 12, 12 times 4 is 48, minus a minus makes that plus, 48 plus 1, I've got square root of 49. I know I talked through that pretty fast, but I figured you all had been working it out on your paper. And 2 times 3 is 6. On the top, that means I have 1 plus or minus 7, whole thing over 6. Because I've got nice numbers on the top, I'm going to go ahead and combine things. Well, -1 plus 7, that's positive 6. So I'd have 6 over 6, or -1 minus 7 would be -8 over 6. And each of those I can simplify. That's a 1 or a negative. Those are both divisible by 2, 4/3. Now, I'm about to let everybody in on a little secret. If you really hate factoring, you can recreate the factors from knowing what the solutions are. I'm not saying you have to do this, but just for fun, if I know that my solutions are x equals 1 and x equals -4/3, I can recreate my factors by making each of these say something is equal to 0. So if I subtract 1 from both sides, I'll get x minus 1 is equal to 0. And the trick is here, I don't want to just add the fraction over. I don't want fractions. So I'm going to multiply both sides by 3. And then add the 4 over to say 3x plus 4 is equal to 0. So I know that that original equation must have factored as x minus 1 times 3x plus 4. Just for practice, multiply that out and make sure I'm right. I think it should work. Looks like it matches to me. Good times. You good? Can I flip a page? I want to talk about just a couple of things that can go wrong when folks are simplifying quadratic formula. So these are just some things to be careful about. And the first one is that if I had -x squared plus 9 is equal to 0, totally fine to use quadratic formula. I'm guessing you probably wouldn't use quadratic formula to solve this. It would be fine to use the quadratic formula to solve this. But if we're going to use quadratic formula, we really need to think about this as saying 0x plus 9 in there, because A would be -1, B would be 0, and C would be 9. Similarly, I would never use quadratic formula to solve something that looked like 3x squared plus 4x is equal to 0. I would definitely choose to factor that. But if you wanted to use quadratic formula, this says 3x squared plus 4x plus 0 is equal to 0, with A being 3, B being 4, and C being 0. In both of these cases, I would rather factor than use quadratic formula. But sometimes you're like on a roll and just doing a bunch of problems and you're on that quadratic formula roll. So if that's where you were at, just be careful when one of your values really needs to be 0. Another thing to be careful about is, let's say that I solved it down to the quadratic formula and I got something that looked like 6 plus or minus the square root of 12 all over 3. Number one mistake someone is likely to make, hopefully not you, someone else in your class, but number one mistake someone is likely to make would be to write this as 2 plus or minus the square root of 12. I'm not putting an equal sign there because they are not equal. What went wrong? Or how can I fix it? Yeah, divided the 6 by the 3, but that square root of 12 is also divided by 3. So it's okay to think about this as saying 6 over 3 plus or minus the square root of 12 over 3. That's totally fine. This is equal to 2 plus or minus the square root of 12 over 3. It's fine to like split that up into 2 fractions to simplify, but they don't both simplify. This isn't so much a mistake, but it is something that happens occasionally that is useful. Sort of similar to what's going on here. Let me make a, okay, about 24 plus or minus the square root of 8. No. Okay. I'm trying to do something cool and it's not working. Yeah, whatever. I'll just take it. It's fine. Square root of 8 over 2. Fine. We'll do this. Okay. If I wanted to break this apart correctly and simplify things a little, I can write that as 24 over 2 plus or minus the square root of 8 over 2. And that 24 over 2 certainly is I can write that as 12. And there is something sneaky that occasionally the answer in the back of the book will have done to that square root of 8 over 4. And that is to think about that, sorry, that's the square root of 8 over 2. I said 4, I wrote 2. Square root of 8 over 2. But the sneaky thing that the book sometimes does when it's writing an answer is to take that 2 and stick it back inside of the square root as a 4. Now, if you're asking yourself, why would I do that? So that you don't have a fraction anymore. This is equivalent to 12 plus or minus the square root of 2. And very often, if this is the answer you got with quadratic formula, this is the one you're going to see in the back of the book. So if you think you should have a fraction there, one thing to check is, what if I take the bottom and stick it inside the square root? I know it's weird. Should I practice another one of those or give you another example of that? Question. Yeah, totally. Why did the 2 turn into a 4? So I think the thing that we have to recognize is that 2 is the square root of 4, yes? So if 2 is the square root of 4, then when I see the square root of 8 divided by 2, I can think about that as the square root of 8 divided by the square root of 4. And when we have multiplication or division, we can put that all together under one square root. So there's another alternative method for how to get there that I'm going to borrow from the chat here, which is the other option is to take that square root of 8, like the other option to get to this final answer would be to look at that square root of 8 and think about the square root of 8 as the square root of 4 times the square root of 2. Right, and that whole thing was over 2. And then to take the square root of 4 and have 2 square root 2 over 2 and make them cancel. Either method works. And I think just sort of like having the numerical fluency to go back and forth between those two is super helpful, especially when you're checking your answers in the back of the book. And I keep saying back of the book, I should stop saying that. In the modules, there are solutions. Because there is no back of the book in digital land, apparently. We just have a couple minutes left. Did anyone have any random questions? I don't really have another example to go through, so we can just wrap it up early. For Friday, we're going to be completing the square. If that's a phrase that strikes fear in you, don't worry about it. It's algebraically kind of annoying, but it is a thing that we need in calculus. So good times. I will see you all on Friday or in office hours tomorrow.